start by taking a look at the lab, at what you're supposed to do, and see that it's not as scary as it might seem. Okay, so a counter is a sequential circuit that goes through a sequence of steps upon the application of input pulses. So what often happens when people get to this lab is they're concerned and say, oh, I have to make a counter. And okay, well, how do I make a counter? Well, we did all that stuff about counters early on, and there were like these D flip-flops, and how do I do it? So the deal is, now that we're dealing with finite state machines, you don't have to worry about how the counter works. What does a counter do? It counts. And so you give one number, and then you give another number, and then you give another number. And how do you know what number to give? Based on the last number that you had. And that's all a counter does. And so what a counter does is, we're used to counters that count in a normal sort of way. So I would expect a counter that counts, maybe displays a 1, and then displays a 2, and then displays a 3, and then displays a 4, and that would be an up counter. And I know what the next number is. It would be 5, because 5 is what comes after 4. But I could define a different count. I could say, no, I want to have an even count. I just want to count even numbers. So it would display a 2, and then a 4, and then a 6. And I can make up any order I want. I can say, no, I want you to display 7, 4, 3. And those are all the numbers there are. When you get to 3, you go back to 7. 7, 4, 3, 7, 4, 3. And that's how we count from now on. The number that comes after 7 is 4, what comes after 4 is 3, and what comes after 3 is 7. And that's a counter. And so all that is a finite state machine where your next state is determined by what state you're in. You just know what the next state is. It doesn't matter what, there aren't any inputs. It's just that's what the next state is. So it's a real easy finite state machine that if it's based on the clock, then you're going to have whatever the inputs are, don't care. So you have like whatever state 1 is, goes to state 2 always, goes to state 3 always, until you get to the end of your states, and then you go back to state 1. And so it's, you know, it's a simple state diagram as well. And then your output is going to be however you are displaying that count. And that's the other thing that's new in this lab, is you're displaying the count using the 7-segment display. And so here there's some discussion on how the 7-segment display works, and you should read that, but I'm also going to talk about it in here, and we'll practice with it. And then there's some discussion of the case statement, but I believe I've used the case statement. Haven't we used the case statement? Yeah, I've used it, but I'll talk about it again if you were interested in that. Well, not if you're interested in this, how I'm using it. And then at that point, you'll be ready to do it all. So let's take a look at what it is you're supposed to do. So if you look at the pre-lab, it says you'll design and build a synchronous 3-bit counter. What that means is, synchronous means on the clock edge it counts. So you'll have a clock, and it'll go to the next number when you advance the clock. It's not an automatic clock. You'll have a button or a switch that'll act as the clock. A 3-bit counter just means that you have up to 3 bits to use, which means you have up to 8 states, 0 to 7 if you count 0, or 1 to 7 if you have a reset state. And it's supposed to loop through the following count sequence: 7, 5, 0, 4, 1, 3, 6. So it should go 7 to 5 to 0 to 4 to 1 to 3 to 6 to 7 to 5 to 0 to 4 to 1 to 3 to 6, and so forth like that. And so to show you what it would be like, I have it here, but what my program does is the 7-segment display is messed up because I didn't want to just give you all the answers. And so what you see on here is almost but not quite a 0. And I had it counting just 0, 1, 2, just like not in the same order, because that was for y'all to figure out. So when it starts, well, it has an enable switch. And if it's not enabled, it doesn't do anything. So without the enable, it's nothing. So nothing happens. As long as the enable is on, when you press the clock button or the clock switch, whatever you do, it'll start counting. So this is counting, that's supposed to be a 0, but it's messed up on purpose. And then mine, I think I have it go to 1. That's a 1. And then it skips 2 and goes to 3, but it's a messed up 3. And then 4, 5, 6, 7, and then it should go back to 0, 1, 2, or 1, 3, 4, 5, 6, 7. That's the order I had it go in on mine. Okay, so that's just to show you that that's all it does, except yours will have the numbers 7, 5, 0, 4, 1, 3, 6, and yours will be displayed correctly instead of incorrectly, like mine are. And you'll know who copies it just straight from the video, because they'll say, why are my numbers look all funny? Because they'll have the ones that look like this. I can go print out a couple more of those if there's interest. Those of you, a new handout, a blank handout, 3.
Yes.
Okay, let me just print those out.
Yeah, I got stuck in the elevator for a little bit.
Oh, it does that, yeah. Yeah. And it's,
Don't trust it.
no, don't trust it. It's kind of funny, and you'll see why later. I say I think the elevator is my personal punishment, and I'll explain why. So there's 4 places where you can display it. The program I just did them all on the rightmost one, but you could do them on any one, and you could have the different numbers display on the different ones if you wanted to, and I'll show you how to do that. That's not hard. It's just a little bit of a change to do that. So the lab description doesn't tell you which one to have it on. It just says you have to have a clock and an enable. So first, let's talk about how the 7-segment display works. It's called 7-segment because it is made up of 7 different segments that are labeled here A, B, C, D, E, F, G, and the decimal point. Most years I use the decimal point, but that makes it 8 instead of 7, and then that makes it different, and so then mine's not really what y'all's is supposed to be, and so I decided I would just follow the instructions. So if you look at it, we've got A, B, C, D, E, F, G. So A, B, C, D, E, F, G. And each one of those is associated with a different pin on your constraints. And so if you go to your constraints, you'll see under 7-segment display, you have pin W7, pin W6, pin U8, pin V8, and it has the names seg0, seg1, seg2, seg3, and so forth. And then if you look at this diagram, you see that W7, W6, U8, V8. And so I always name the variable for my 7-segment display. I always name it seg, because then I don't have to change the name when I copy it from the constraints. So my 7-segment display is always seg0 through seg6, and that's just going to be my name of it, so I just don't have to change the name. And seg0 corresponds to A, seg1 to B, seg 2 to C, and so forth down to seg 6 is G. So in this example, if I wish to make the number 7, I would want the segments A, B, and C to be illuminated, and D, E, F, and G to not be illuminated. So that would make the number 7. So spend a second just to figure out how you would write the numbers 9, 5, and 3 using this little grid. So like what segments you would have lit up to make 9, 5, and 3. Just like that's 7, and that would be 1, and that would be 0. How do you do 9, 5, and 3?
Is it standard to like the bottom bar for 9? Like instead of just having like a straight line on the right side?
That's a good question. I don't know the answer to that.
I just assume it's straight.
Yeah, I don't know. I don't know if there's an answer to that. You're not going to get it wrong, however you do it. Okay, so who wants to tell me how to do 9?
Is it A, B, C, F, G?
A, B, C, D, E, F, G. That's how I would do it. The question was, oh, that is standard. The reason why is because I would use the other one to stand for a lowercase g.
Also, it's more work for yourself.
It's more what?
It's more work.
Yeah. So we had A, B, C, not D, not E, F, and G. I think that's normally 9. Okay? And who wants to do 5 for me?
A, C, D, F, G?
A, B, C,
D,
D,
F, and G?
F, G. Yep. A, not B, C, D, not E, F, and G. And 3.
A, B, C, D, G.
A, B, C, D, and G is 3. A, B, C, D, G. Yep. Okay. All right. So now y'all see how that works. Now let's assume we have the following constraints. So we just get this from the file that I put up there or somewhere else off the web. And then in our program, we defined seg to go from 0 to 6, and we're making it output reg. So we're just going ahead and calling it seg. And so seg 0 refers to pin W7, which was A on the page before. Seg 1 refers to pin 6, which was B, seg 2 to C, and so on. So this, what we have up here, that's the same as A, B, C, D, E, F, and G. So now, if I have a 7-digit binary number, what number did I have there? 0, 0, 0,
1, 1,
1,
0, 1.
0, 1. Okay, so here's a 7. If I set seg equal to this, and I have seg as going from, notice I have seg going from 0 to 6. So seg 0 is 0. Seg 1 is 0. Seg 2 is 0. Seg 3 is 1. Seg 4 is 1. Seg 5 is 0. And seg 6 is 1. So if I set up my constraints and my declaration that way, then I can make a 7-bit number to tell me exactly how I want each of my segments to be, if I want them to be on or off. And so rather than doing them individually, I define the whole thing with this 7-bit string. Now, the thing that is interesting about it is 0 means on and 1 means off. Yep. So if I have 0, 0, 0, 1, 1, 1, 4 zeros and 3 ones, then A, B, C, and D would be illuminated, A, B, C, and D, and it would leave E, F, and G off, making a shape like I just drew up there. That would be seg equals 0, 0, 0, 0, 1, 1, 1. Okay, so now I want you to look at the 4 examples I have there and see if you can tell me what those should look like. Remember, 1 is off and 0 is on. So I'm assuming those of you who aren't doing anything already did it, because I'd be really sad if I went to all the work to make these problems and y'all didn't try them. But so the first one, if I'm thinking of it right, should just be a line in the middle. That's just the very last one. So of our 7 segments, it's just G, just that middle one. So just that middle one there, because all the ones up to that are off. The next one, they're all on except for the middle one, so that would be a 0. The next one, I have the top is on, so A is on, B is on, not C, not D, and then E and F are both illuminated but not G. So it kind of looks like that. And then the last one, we don't have the top, but we do have the 2 sides. We don't have the bottom or the bottom left, but it looks, I think it's a 4. Did anybody get something different? Okay. So that all makes sense? Okay. All right, so spend a little bit of time. I am not going to go over the answers to these. This is for you to do. To determine any of the string patterns you'll need to display for this or future labs. So this is just for you to go ahead and get your, if you go ahead and get it now, then you won't have to get it later. And you don't need all of these for this lab. I just put them all up here in case you wanted to have them have them for later. But just spend a few minutes filling some of these in. And like I said, I'm not going to go over these because I'm leaving something for y'all to do. So, does anybody need help figuring out how to do this? Okay, I'm going to pause it and give y'all just a minute to work on. And I didn't mention it, but the 7 and then the little single apostrophe B is telling you 7 bits and that it's binary. So that is important because if you change the number of bits and you don't change this number in front, it's not going to work the way you think it does. It won't actually give you an error. It'll just read however many it can read. So you do want to make sure you get your numbers right.
So if you put 6, you then put 7 bits, it just stops at 6 bits.
That's right. And you don't necessarily know what your error is, like why it's not working. You also want to be careful because if you type this like in Word and then copy and paste it, a lot of times it'll do that single apostrophe as an accent, and then that'll give you an error. So it really has to be the single apostrophe. Yeah.
Does lowercase b look like 6? I don't know if you know that.
I do a 6 like that,
Oh.
and then a G, a lowercase g, if you had to, like that.
So you just add the extra layer
Yeah.
on it.
Yeah. That's
There's
the
nothing
best
wrong
you can
with
do with 7 segments.
Right.
Okay, well, I'm going to pick back up. So if you didn't finish, that's okay. You can finish later, or you might not need them. So that's just so you have that handy. It'll make things easier. But then to display the number, you also have to tell it which of the 4 segment displays to use. But it's a 4-bit number. You're not just telling it which one to use. You're giving all 4 bits, saying which one of the 4 is activated and which one is not. And so I think in the original handout where this was described in 2741, they used the variable a. I use an again from laziness because that way I can just copy them straight from the constraints file. And so in addition to the 7 segment display right here, these lines seg 0 through seg 6, you also have to have AN0 through AN3. So you also have to have those. You don't have to have the decimal point in between, but you do have to have those. And that value will tell you which one of your 4 you're using. So if you want to use the rightmost display, 0 means it's on, and 1 means it's off. And so this 4-bit number it's got 4 bits. This one is for the rightmost one. And this one is for the leftmost one. And you put a 0 in the one you want to use. So if I want to use the rightmost one, I make this 0, 1, 1, 1. And I just let AN be that. If I wanted to use the leftmost one, I would let AN equal 1, 1, 1, 0. And so you're also going to have an output AN. So you'll have an output seg, and you'll have an output AN. And it's going to go from 0 to 3. And depending on whether or not you're changing it or not, will depend on whether you need to make it a reg. So if you're just going to keep the same display the entire time, and you're not going to change it, you don't need to make it a reg. You can just make this your variable. That's where you declare it as your variable. And then you just, not in an always block, you just, at the start of your program, you assign what you want it to be, and then you're done. If you want to change it, if you want your numbers to show up on different displays, so it's moving along, then instead you would have output reg, and then whenever you give it the new seg string, you also give it the string to show it where you want it to go. Okay. So our state diagram is going to be pretty simple, as we only have one input besides the clock, and that input is the enable. I believe you're supposed to have a counter that runs through 7 digits in a certain order as long as it is enabled. So each state will correspond to an output of that number. Okay, so how many states will we need?
I think some with like 2 to the end, but I forget what it's greater than or equal to. I forget what number it's supposed to be.
We have to have, so that'll tell us how many bits we need, the number of states we need a state for each number, and then also a reset state. So we need 8.
Okay.
So we need 8 states, which means we'll have a 3-bit number, because 2 to the 3rd is 8, and that has to be bigger than or equal to this number.
Is that also for number of flip-flops? I
Mhm.
know we aren't doing flip-flops.
Same thing, yep. And so, let's see, it was 7504. Seven 504-136. Now, I don't think the program specified. If it did, the lab specified, if it did, you'll have to go back and look at it. I had mine, if it was not enabled, I had it go back to reset. You might have it that if it's not enabled, that it just stays where it is. I don't know if it says. We could look. I don't see anything that says. So I think that would be like your call, the way to do it. So our only input is the enable. Otherwise, it's going to look like that. And all of them would have, this would be enable equals 0, and this would be enable equals 1.
So A.
What's that?
Is that A?
EN, enable. I'm just using EN as the variable for enable. So I'm just saying if it's enabled, it'll just count, it'll go to the next state. And if it's not enabled, I had it go to reset. You might choose to have it go back to itself. That'll be your choice. Yes, you could do that. Yeah.
If you have 8 different states and a reset.
Oh, were there 8 different ones? No, because there's no 2.
Yeah. Is it 7 states and 1 reset, I thought?
I thought it was. Yeah, I made up this number 8. That's not there. Yeah.
So it just goes straight from 6 to 7? And
6
then,
to 7.
and then back to
Yeah.
reset.
Well, it doesn't actually, reset is not part of the counting sequence. Reset is outside of the counting sequence. But it does go from, if you are at reset, it goes to 7. Let me draw that neater. Can someone tell me the count sequence? 7.
5, 0, 4, 1, 3, and 6.
So that's how I did mine. If it was not enabled, I had it start over. And my reset, if you were on reset and you got a 1, you went to 7. Because I had that as my first number. So reset,
We can make them go into themselves.
I don't see why not. I didn't see it really specified.
So the error is just if it's enabled or not.
That's right. And I'll tell you why I had it go to reset instead of back to itself. Was a silly reason. Was because this always block, which is where it goes to the next state. If it's enabled, it goes to the next state. Else, if it was just going to stay where it was, I didn't want to write current state becomes stays current state. I didn't want to have the the needless line to say it equals itself. But Vivado would make me put it in there because it would say, oh, you might not, you have an if that's not complete, and so you have something that's not specified, and it would fuss at me about that. And I didn't want it to fuss at me, but I also didn't want to say current state equals current state, and so I said I'm going to make it equal reset state. So it was no good reason for that other than just my wanting to have something in that else.
But it is permissible to use current state again, right?
Yes,
Okay.
yes. So if you wanted it to stay where it was, you would just say current state. So, yeah, and that'd be the only difference. I just didn't want to do that. It just makes me mad that I have to. Okay.
How does it determine if it resets? If you get a 1, where to go?
Say it again.
Like if you're at reset and you get a 1, how does it know which state it is?
Because reset is a state, and the next state from the reset state in mine is 0.
Oh,
The next state in yours would probably be 7. Okay, so then the next thing for you to do is just to, this is just for you to have your own information here to gather it. I decided to have names for my states. You don't have to. You can have your states, like here we have numbers. We can't use numbers as variable names, but I could easily call my states by their binary values and never use any names at all. That would be fine. There's nothing wrong with that. I could call them that. I like using names because for teaching purposes, it's a lot easier to say, oh, this is state 2. It corresponds to 2. So I like to give them names. You don't have to. But we do have 8 different states, and so that corresponds to 8 different binary numbers, and you can assign them however you want. I assigned mine according to the number that it was. Like, I did, but that's because mine were also in order. My states went 0, 1, 2, 3, 4, 5, 6. So you could make your state 0, 0, or you could have the numbers be in the order that they're counting. It really doesn't matter. It doesn't make any difference. You're never going to deal, once you define them, you're never going to deal with it again. It's just, if you give it a name, you just want to make sure that you use all the values and you don't reuse them. So, like, you could do 0 is 0, 0, 0, and this is 0, 0, 1. Or you could say 7 was 3B, 0, 0, 0. Or maybe 7 is 3B, maybe reset is 3B, 0, 0, 0. And 7 is 1. And then what comes after 7? 5, and 5 is 2, 3B, 0, 1, 0. It really doesn't matter. You just have to use the binary numbers from 0 to 8 to fill this up. But what is important that you know is if you use names instead of numbers, what the next state is going to be after each state. You'll notice I didn't put a 2 in here because y'all don't have a 2. It wasn't one of your count numbers. Yeah,
What does the output binary number correspond to?
your display.
So it should be displaying a number of 4, correct? With that binary.
No, it's displaying 0 because it's in 0 state. The next state is 4.
Oh, it's just saying that the current state.
This is the current state and the current state's output.
Okay.
So the output should correspond to the current state.
Okay.
And if we're doing the it's going into itself, we don't have to use the last reset state right there. We can just ignore it.
You still need to have a reset state because you need to have something for it to start in. Do you have to have a reset state? I don't know that you have to have one, but if you don't have one, you do need to make sure that you have a default in your case statement, because then you're not going to be using all of them. So if you don't have a reset state, then you would want to make sure, like in mine, you'll see that I start with, when I define them up here, I have my current state. When I define it up here, I say start in state 0, 1, 0. So if you want to start in state 7, whatever state that is for yours, you would put that in here, and then you wouldn't really need a reset. So you could do it without a reset. Okay, so that's just for you to gather your information. So now let's talk about the structure of your program. What are your inputs going to be?
Enable and clock.
Enable and clock. And enable is going to be a switch, and clock is going to be the clock that we've used for our other finite state machines. So you would need to get any switch you want to use, just make sure you know which one it is. So I used the one on the end, V17, and make sure you remember, it's like every time I do one of these things that has an enable, I forget about the enable and I first program it and it doesn't work. And I'm like, why doesn't it work? It's like, oh yeah, it has to be enabled. So it has an enable, and then you have to have these lines for the clock. These you don't have to have that J1. J1 corresponds to using this, which I really like. I don't know if any of y'all have played around with using this as a clock. I just find it so much more reliable than the others. If you use a switch as a clock, you have to turn the switch up and down to make it, and that's like so much more work. Yeah. So, okay, and then so those are our inputs are just the enable and the clock. Okay, what about our outputs?
Segment.
Actually, I'm going to put that under output reg, because we are definitely defining that in an always block. And so it's output reg, and it is a vectored signal, meaning it is 0, it has width 0 to 6. And you can call it something else if you want. I'm just all about being lazy. Yeah.
In the regular output, you'd have AN.
Regular output, you'd have AN 03 AN. Whoops. Unless you want to change the display that it's on, and I think like this program, I think that it's easy enough to see how you would do that. You would just, rather than defining it once in each. Like here where we filled out our table that had the output, you would have another column that would have your AN. You'd say what AN do you want it to be on, and then you would just like have both of those. And so that way you could have it like travel if you wanted to have that. Okay, and then okay, what about reg that's not input and output? You know, we always have these in finite state machine programs. Remember I told y'all that when we look at a Verilog for finite state machines, you're always going to have two always blocks. And your first always block is going to always be an always at.
Is it begin?
The current state?
Current state. So whenever you have one of these finite state machines, these can also be inputs and outputs. It's possible to make them not inputs, it's possible to make them outputs. But you will have current state and you will have next state. Now, how big are these? Like how many bits are these?
No,
3. So I have them 2 to 0, current state, next state.
This may be something old that you've covered or has been covered. Do we have to do 2 to 0 for the next state as well? Or is it count for both of them?
If they're in the same line and they have the same width, you don't have to do it. So if I wanted one to be 2 to 0 and one to be 3 to 0, I'd have to do them in different lines. But if you see, I have them in the same line without it. And no, I don't think anyone has asked me that. Okay, parameters are optional, but this is if you want to give names instead of binary numbers to these states. So if you want to do something like a reset state, equals 3B000, or if you wanted to give a name to a string, like one string equals 7B1001111. Just to have, so you just put those in one place, and then you refer to them by name instead of by number. If you don't do that, then what you would have here, so if I didn't have these parameters, so I put them on different lines just because, just to keep them separate. So I have, I put the parameters for the names of the states, and I put the parameters for the strings. What I would do here, rather than having these, I would have, what is my reset state? Reset state is 010. So rather than having names in all of these places, I would just have their numbers. So you don't have to use names if you don't want to.
If you for whatever reason had names and then switched your code to be exactly like you just did, but it's still
This will run just fine. Like
Okay.
what I just did didn't change anything.
okay.
Okay, initializations. So I wasn't sure about this, but I figured, actually I don't know how mine works. Let me see, let me try it. I'm gonna reprogram it. Program, it is enabled. Oh, I have it starting in the zeros at the reset state. Yeah. Okay. So I had mine. I gave it a state like right up here in the current state. I told it where I wanted it to start. So when I defined it up here, I said to start. That's where it's going to be. I don't know what would happen if you didn't do that. It probably. We'll try it out and see. We'll let this compile while we talk about some other things. By the way, when you do it, you're look at your schematic, what it should look like. Where'd everything go? I'll wait till it finishes compiling. Okay. So initializations, you'll want to tell it where to start. Where does it advance to the next state?
Every clock.
Say it again.
Every clock.
Every clock, and where in the program is that?
That'd be at the end, wouldn't it?
So the way your overall structure is going to be is you're going to have these inputs that we talked about. You'll have your outputs. You'll have any other regs you have. You'll have, if you have any assigned statements, you'll have that. And then you'll have one block that's always at current state. And that one's going to be where you determine what your next state is. And that one always has a case statement in it. And case current state. Dot, 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 end case. And then you'll have a second always block. And your second always block is where you actually advance. So your second always block will be always at pos edge clock. That's where it'll go to the next state. Where do we want to put the enable?
Did you put it on that one with the clock?
Yeah, it works best to put it with the clock because the enable is part of determining whether or not you're going to go to another state or not. And so you'll have in here, you could have if enable equals 1, or you can take the shortcut and just have if en and say what to do if it's enabled. If it's enabled, you want the current state to become whatever you calculated the next state is supposed to be in the other always block. Else, you want it to do something else. And I had mine be that it went to this reset state, current state equals reset state. You could just say here else current state equals current state. I suspect it would give you an error if you left that out. You'd think, well, why do I have to tell it to stay where it is? You know, and that's why I didn't do that, because it makes me mad that I have to tell it that. But you do. Okay, and then what is the first always block? So what does the first always block do?
Updates the current state.
Updates the next state. It also updates the output. So once the clock edge tells you what the current state is, the second always block says, well, if you're in this state, oh, I'm so sleepy. If you're in this state, this is what your output should be. So in the first always block, which is always at current state, depending on what state you're in, that's why it'd be a case statement, case current state, you're going to do two things. So like if I'm in my case, for me, if I was in my case 1 state, I have a colon, and then I have begin, and then I had seg equals 1 string. So I want my output to equal whatever my current state is, and I'll have next state equals whatever comes after 1. For me, it was 2. Next state equals 2 state. I'm sorry, I know that's not legible. Let me just move to my code. So we have so always at current state, case current state, and then you list all your states, and you say based on whatever state you're in. If I'm in state 7, I want my next state for me, I wanted it to be the 0 state. I wanted my segment to be the 7 string, and I have a begin and an end. You don't actually have to have a default if you're using all 8, but it's always good practice to put 1 in. If you're not using all 8, you definitely have to have a default. Yep.
If you didn't use the parameter to name 7th state to the binary number, would you just put the binary number there instead of 7th state?
Whatever that state was, whatever the number for that one is, you would put it there. So like mine, is it 111? It was 111. So.
And you have to do that if you do not define
The parameters.
Okay.
Yeah, but you can mix and match. I mean, you shouldn't. I mean, that's not really helpful for someone looking at it wondering why I did that. But this works exactly the same.
Does it matter what order? Like if you put 7 state before 1 state? Okay.
Doesn't matter at all. Oh yeah, that table does that.
It does do
So let's see. I want to. So this time I didn't initialize where it went to. Let me see what happened. So first of all, if we look at my schematic here, see if this makes any sense. Does this look like what we would expect it to be? what's that little trapezoidy thingy there?
Multiplexer
And what does that mean? What should that correspond to in a program?
makes a decision.
Yeah, and so where do we have an if?
Or else.
Always plot.
Yeah.
Plot.
So, so that's that one, and that's telling us something.
There's a multiplexer for the enable. If the enable is on.
It should be for the enable, and you see you got the enable going
Going
into the
into it.
multiplexer,
Yeah.
and then we've got current state and next state. We've got a stack there of D flip-flops. That's our register. Those are, I don't know why there's 4 of them. There's our output. Anyway, looks good to me. But let me program. And it automatically started at the reset state, which is what I had as the default. So it used the default because it didn't have anything. So when I had it without, so that's a good reason to put a default in, even if you're using all 8. Because it's not, when you start it, it's not defined, so it doesn't have anything, so it's using the default as where it's starting.
What did you make your default?
Reset.
What would happen if you didn't have default?
I don't know what it would do. We can try it. It might give an error. If I didn't have the default and I didn't initialize it. It's fine without the default when I initialized it because I've tried it out, it worked. So let's see. So are there any questions? Yes.
For the state table, I don't understand like what do we put for the next state. So I know for like the current state we put like the binary values from like 0 to 7. But like for the next state,
Well, where's it going to?
right?
That's what the lab tells you is it's a counter that goes 7504. So so if you're in state 7, your next state should be state 5.
Okay. And the output would be
Your current state, the string that goes with your
the
current
string.
state.
And it's just because yours is different, that's why yours goes to state 0 or whatever, but ours is supposed to be a file.
Right. And mine's different on purpose
Yeah.
so that people know what they're doing and don't just copy it. Yeah.
Can we kind of like look through your Verilog code?
Yeah.
And step through?
Yeah, absolutely. I mean, like right now?
Yeah.
Okay, so yeah. So, but keep in mind that there are a few things here that are different. And I'll point those out when I get to them. Okay.
I'm sorry.
So it mostly follows the structure of what I had on that page that says structure of the program. So we have whatever you're going to call it, and you have your inputs, clock and enable, and your outputs, whatever you're going to call them. And then your 2 inputs, your 7 segment is going to be an output reg, your AN might be reg, it might not be, depending on where you do it. You will have a current state and next state, and those will definitely be reg. And those are 3 bits, 2 to 0. And then I named my states because it makes it easier for me to talk about with y'all if I have a name on them. And so those are the names of the different states. And then I have the names of the strings. And again, you don't have to do this. This was just so I had them in one place, and I could reuse them if I wanted to. And it just, also it explains, like when I'm trying to explain this to someone and I just have example like this, and I'm trying to explain, someone sees this, they have no idea what that means. But so I have those names. And then because I kept it all on the same display, I did assign AN equal to that. If I wanted to change the displays, I would do that within this next always block. Then you have an always block, and it's always at current state, and the case is at current state. And then you're going to list your states, which will either be 7 or 8 of them, plus a default. So you'll have 7 or 8 plus a default. Even if you have a reset, you need to have a default. And these are either going to be the names of the states or just the binary numbers that go along with those states. Then for each state, you're going to have, you'll have the name of the state, you'll have colon begin, and then you'll say what the next state is going to be, so where you go to from that. So for me, from state 3, I go to state 4, because I count in order. For y'all, from state 3, you go to 6. So your next state would be 6. And then your segment is going to be the segment that you want to display when you're in that state. When I'm in the 3 state, I want to display the 3 string.
Which is your 7-bit 001. Okay.
Mm-hmm. Yours would also go along with whatever state you're in. So those will still match up. Now, if you wanted to change which display you were using, it'd be right here. You would say AN equals, and you'd say when I'm in state 3, I want to be on the second little thingy.
And then you'd have to register AN.
And then you have to register AN. Yeah.
So
Yeah.
the segment, or if they're named basically the same thing, it would correlate with the current state.
Yes, yeah, y'all's would too. This is the state you're currently in. You want it to display the state that it's currently in.
So,
No. So when our current state is like 2, for example, our output would be 2 the string 2.
Mm-hmm. Mm-hmm.
So for us to do 20 though, we would do second state and then AM for the second position, right? The AN's just to correlate which number on the display you want, right?
Right. So if you wanted to have it on a different display, if you wanted to change the displays, you do reg here.
Mm-hmm.
You would take this out, and then on each one of these, you would have
For your default, does it pop up anything, or is it just a blank screen, or like display?
for my default. My
I guess
default has it.
doesn't matter.
It doesn't matter. I thought it was best to have it be. I took it out to see what happened. Let me see. But mine, I had it be the reset state, which in the string for the I had it is 11111. So I gave it a string. So to display, yeah, basically display the like the 8, but all blank, all off. So let's see what happens when I run it now.
So if we were trying to do it towards not resetting, it's just going back into itself, the default would be next state equals current state, and then current state equals current state.
No, not quite. Hold on, I'll get there in a second. It seemed to do just fine without the default and without initializing it. So, okay, say it again.
If we were doing it goes back into itself
Mhm.
when enable is 1. And do you have to use the default and say current state or next state equals current state, and then current state equals current state? Because you have it to
Okay.
where next state is the reset.
So you can't, the default is not in the always block. I see what you're saying. Okay, so first you'd have to have this in your second always block. And then up here for your default, you can make your default be whatever you want it to be. But So I would say default. I wouldn't want default to be current state because the problem is, what if it's not defined? What is it gonna do? And so I would just pick a state. So that's the way I do it. But different people do it different ways. So I usually make my default like the first state or something like that. So I would do it like 7 or something.
It would be the next state or the current state.
Your default should look exactly like these. So it should be exactly like these. So begin, next state equals, and just pick a state that you want, 7 state. And tell it what you want it to display. So the default looks like any of the others. But you can also put don't cares in there, but I don't want to talk about that yet. Yep.
Nothing else.
Okay. Okay, so you have your first always block that has case, current, state. You list out all your states. For each state, you have a begin and an end, and you have what the next state is, what the seg is, and if you want to, which display it's on. Then at the very end, you have a default. And it looks like any of the others. You're just picking a default. And you have end case. Since the only thing we have in this always block is a single case statement, we didn't have a begin and an end on the always, so I didn't have to end the always. I do have to end the case. And then my second always block, always at positive edge of clock. If enable, do one thing, else do something else. And so it's a pretty straightforward program. Okay, other questions? Yep.
Do you know if you have to include the programming for the pre-lab this time?
What you have to include for the pre-lab, not the program, although I recommend that you type it up ahead of time. You need the state diagram. It says, and the number of flip-flops to realize all the states in the state assignment. So you basically have to do the table that you've already kind of done. Yeah.
If you scroll up on that one, it says that we have to walk in the lab with it. It's like the second paragraph.
Oh.
I saw it before the lab.
Oh.
It's not the pre-lab work, too. They have like a whole pre-lab section.
Yeah, but it says it right here.
Through grade scope, but
Yeah.
they said they're going to be expecting whenever you walk.
Okay. Yeah. So I would have it.
Wait,
It's
what?
They always say that.
Oh, they do?
I mean, I think so.
it's better to have it. I mean, if you have it, you don't have to do it there, and you can be done.
Can
I
we
mean-
download the bottom?
It takes a long
It takes
time to
it's
download.
very
The
very
bottom
it's
of it
very very
took
large.
like an hour to download.
What's the online one?
And it's complicated to like pick specifically what Vivato you want because there's numerous different programs inside of Vivato.
I had a handout on how to do it at one point. I did not post it this semester. I still could. So it's EDA Playground.
Wait, what?
One flip flop per bit.
Oh.
So
There's 8 states.
the N is the map of flip-flops.
Yeah.
I also have. Did I make a handout? Hold on. Let me see if I
We
have
don't have to
this.
draw the flip, right? We just.
Oh, no, just the state diagram.
So just draw a state diagram and then it's 3 flip flops.
Yeah.
Yeah. So we just gotta say, hey, there's.
Yeah. Yeah. You don't have to do anything with the flip flops.
It's a pre-lab.